because we have a little something to give. Well, right now I'm going to give something to Tim, actually, because he spoke in this conference. So here in this little act, I'm giving you a certificate of, from the International Society for Computational Biology.
Just place the thing.
Yes. Well, yes. You can return it if it is faulty. Okay. Yes, I spell it right. Okay, you're welcome. Okay, thank you. So, and when you say try Adekar come in, let me know because I have his. Okay, so to finalize the conference, which I think it was very interesting, very yeah, a little picture there, nice. I think that there were a number of criticisms or thoughtful comments that were being voiced that I think it would be very interesting to start to discuss them now. And because some people I know have to leave, I would like to hear them first, you know, Boris and...
Hello, thank you. So I wanted to make a couple of comments. I've been, to some extent, not directly, but to some extent involved early on, and I've been able to come back occasionally. So the fact that I'm not here year to year is unfortunate, but at the same time gives me some sort of a distance. And I've noticed some recurring problems. But not to start talking about problems first, I wanted to say one other thing that I've noticed recurringly happening. And that's a trend towards not just in silico data sets, not just real world data sets, but sort of a combination now where the in silico and real data sets supplement each other. And that's great, I think. That's phenomenal because you can see that the algorithm does well in both cases. Now, as far as things that I've noticed, I wanted to bring up, first of all, that various groups submit algorithms, some of which do use priors and others don't. They use different priors. It's not always clear, I think, to people which priors are interesting. It depends on really on biological experience of the groups. And so it would be interesting to sort of separate the submissions into de novo submissions and submissions using priors. It almost seems to me that the exercise of selecting priors is sort of a challenge in itself. And it's of tremendous importance, of course, for real world problems. Secondly, I've noticed that problems change. It's true because our data changes. There is constant improvement in instrumentation, and therefore we get better and better data every year, bigger data as well. But at the same time, and so do algorithms, of course, but at the same time, because the data changes relatively quickly, and the competitions change with it, it seems like the algorithms that do best vary from year to year. It's not clear to somebody who would come in off the street more or less and try to learn about systems biology, what works in this space. So I was wondering whether it might make sense to consider maybe a model redux, taking a model from a year past, especially an in silico model from which you can regenerate more data, maybe with slightly different structure, but where we know what works for a particular structure. And have people submit from the current crop of available algorithms and see whether there is an improvement compared to what previous algorithms did. Just a thought. Lastly, what I've noticed is that rarely, but again, unfortunately somewhat regularly, there are these minor controversies erupting around the understanding of what types of features in the data were off limits or not. So I don't know how this problem can be solved. Clearly what is considered data apparently can differ from one researcher to another. And I think this would probably take some work, but essentially one suggestion that I wanted to make, maybe this is already being done, is that part of creation and approval of a challenge should involve a look at which unusual features in that challenge could be, correctly or erroneously, by the way, perceived as being unfair, where some people would say, oh, that we shouldn't have used that, and others would say, oh, this is totally acceptable. And I think then it would be a little easier to interpret results for these competitions. Thank you.
Yeah, sure. The only one thing I was going to add is, compared to, say, the early Dream 3 and 4, where it was all synthetic data, now it's real biological data sets. They're heterogeneous. They're clinically relevant. That's awesome. And I think, we all seem to agree that prior knowledge helps. It helps a lot. I think that having a section that's for de novo submissions and another section where people use prior knowledge is great. I think also, to Boris's point, you either include as part of the challenge a set of priors to use that could be faulty, could be noisy, or you make a separate challenge around curating and collecting prior knowledge. I mean, Ingenuity kind of has that, right? So I think that that's kind of a big question going forward.
So there were many topics there. So one was reuse of previous algorithms. One was in silico versus real data. One was prior. So anybody wants to comment on this? I think this.
Yeah, I was just going to say that I think that the idea of creating de novo challenges where you don't have any biological prior information is very important, because obviously there are species that we don't know anything about. There are systems that are emerging and need elucidation without much grounding. But I don't think the way to develop algorithms for that application is to do in silico when we can. The way to do it is to have real data, but to de-identify the proteins, or so that you get the behavior from a real biological context, but you don't necessarily have that knowledge attached to it.
So I don't want to be defensive, and I always take this, and all the Dream Team teams takes these comments very seriously. But we have thought of many of these things, as you can imagine. We don't take any of this lightly. I mean, we invest a lot of time and effort to think about this. So when it comes to, that doesn't mean that we cannot change going forward, right? But when it comes to thinking about priors and how do we organize a challenge, it is true that we could try to control for several of the aspects, for example, in a pipeline, normalization, prior, then you say, oh, feature selection is what I'm going to do. And then we say, the classification part, whatever machine learning algorithm you want to use, also will fix. And only feature selection is this challenge. We could do that. And in some cases, we have done that. Of course, when we do that, there are people who say, hey, why don't you let me normalize my way? Because the way you normalize, you don't know how to normalize. Right? The way you do feature selection, is not the right way to do feature. I know how to do feature selection has to be done with the classification. So it's very difficult to, satisfy everybody, because everybody is intelligent and everybody wants to do things their own way. I want to say that the way we try to do things, and I'm trying to convey this because this is really at the core of some of our thinking, again, we can change, is that we want to do a problem as if it were a problem the way you would approach a real biological problem if it wasn't a challenge. So you can use everything that is available to you, any prior. You can use, nature will not tell you what is the scoring function, right? You want to solve the problem to the best of your understanding. And, and there are so many ways of scoring, for example, that saying what is the scoring beforehand might be very clear for a machine learning person, or for any quantitative person. Say, I have my scoring function, I know what to do. But that's not how nature works, right? I'm not saying this is the right way to think. I'm saying this is the way we are thinking, and that informs the way that we decide not to give all the information about scoring, not to give, not to limit people to use prior knowledge and things. So that's what is at the root cause of, your pains. And
yeah, this just occurred to me, listening to this back and forth. It seems like this idea of separating the de novo submissions from the more prior biological knowledge submissions, it seems like it's pointing in the wrong direction of history. So in the sense that it almost implies, it assumes this idea that we've got the computer science, machine learning here, people over here, and they need to give us a module which fits onto the prior that the biologists provided. And I guess what I'm trying to say is the future of this field, this interdisciplinary field of systems biology, I would like to think that it's when the machine learning people look up from their Chris Bishop and their Mackay, and they sort of do a little bit of Wikipedia surfing, and I mean, people who, you've got to get your head out of the machine learning book for just long enough to understand about receptor tyrosine kinase signaling, so that just that attitude of like, well, I don't do priors, that's for the biologists. I tend to think that the most useful real-world solutions are going to be produced by the people who can fathom both a regularized linear regression, but also like the tyrosine kinase cascade. So yeah, that's like not a very precise criticism. It's just my impression of which way the discourse is going.
right, so there.
Yeah, I very much agree with what you just said. Just a maybe pragmatic comment or suggestion. So I liked it very much how it ran in the breast cancer challenge with the real data, but I was a little bit disappointed to see that really the prior knowledge was like so very, very good. And then I thought maybe a good way out of this is for the next year's challenge maybe to at least provide some provide this prior knowledge for the people that are non-expert in this particular field that you will do the challenge on, so that they have a warm start kind of, because of course it takes long time to dig into that, and of course it might be valuable, I agree with you, but sometimes you just don't have the capacity to understand all this stuff that is out there. So a little bit more like help to get, if you are, I mean, if you have to face the issue that people will use prior, then maybe give a help for people that are non-expert in this field to get into that.
So there are lots of people that want to speak. I'm keeping a count in line, but you come. Someone else wanted here, right?
So that's kind of weird to hear a voice like that. So maybe I have the wrong read on this, but I think something kind of at the heart of the conflict here is that the goal is that maybe the goal for these competitions is to try to develop techniques that will generalize to new situations, right? And one of the problems with using prior knowledge is that some of that data doesn't exist for new situations. And I feel like the conflict is not necessarily so much that these people are biologists, so then they do these things, and machine learning people do these things. It's just that as a computational person, when I look at something, I try to find what the like generalizable core of it is, and I guess prior knowledge can kind of muddy that up. Yeah, sorry.
So expanding on the notion of having a biological question or that we want to answer and actually generalizing that, because we'll have more and more biological questions. If that is the purpose, that it seems that inferring network structure and parameters is becoming more and more of an iterative process between experiments and inference. And the experiments vary widely depending on the context. So I'm kind of wondering whether there's any thought of enabling groups to do different sequencing experiments, not just expression, and putting that context into how well you could do an inference.
So you mean in an iterative process of learning from what we learned?
So this is a kind of a response to the two prior kind of criticisms. So as a scientist coming from the scientific side, but also being pretty heavily into the machine learning, I mean, you have machine learning methods are being developed all the time, but when they're applied to the real world, it's kind of a 80-20. You know, 20% of the effort is getting the right algorithm, and 80% of the effort is understanding the bias and the noise in the data. I mean, that's just the way it works, right? And so, I mean, if you want to concentrate on a generalized algorithm, then we should set up a competition where you have a number of disparate sets of data, and the challenge is to do as well on on different sets. But what we've seen up until now are data sets on very specific problems. So, you know, building good priors and understanding the bias and the noise is part of the challenge, unless you construct it in a way to be more general.
Right. You know, I like your idea. I always try to think that, you know, the right way to do things is not doing things through challenges. It's doing things because we have to solve a problem. There is no challenge needed, really. You know, the patient doesn't care about the challenge. The reason why we do challenges is because people like to compete, actually, and pit ones with against each other. So in a way, it's a little bit an artificial way, but I like very much the idea of simply having, you know, scientific question. Many people say, you know, I know how to model it and I know how to measure it, and the other person say, you know, I have done the two of these, and, you know, talk to each other. So that's why, you know, I think the collaborative phase of the present challenge in the breast cancer network inference, I think, is going to be where really the fruits of each other's having understood what the problem is, and now we can share some information, but without the need to compete with each other.
If your incentive is to contribute something to the computational biology community, or to the biology community even, rather than the machine learning community, then you would want to kind of make the challenge as similar as possible to a real situation in which someone in the lab wants to infer the network. And so enabling experiments for validation and having an iterative process could, you know, be one of the sub-challenges.
I agree. We should do that. Come here.
I see the prior problem and the machine learning or the computer science side of the problem is sort of perpendicular. So they are not conflicting with each other. So we should use good prior, and also we should develop methods that adapt to the type of data being generated by the technology we're using today, which is different than from Dream5. Because when we look at this data in Dream8, we notice big difference between some of the characteristics of the data we see versus the one in Dream5. And we see a lot more nonlinear type thing being present in Dream8 data sets versus we see a lot less of that, for example, in Dream5, East, and E. coli data sets. In those experiments, the experimental design at that time with microarray data does not perturb the data sufficiently so that it moves the system from the wild type, which is the steady state, to another saturated state, for example. So there is the importance in this Dream8 actually that shows how the experiment actually is moving the data from steady state to linear to nonlinear transition, then stabilize at the saturated situation. So this is saying that the technology is evolving, so the machine learning community needs to pay attention to getting their algorithm adapting to the type of biotechnology that's used to generate the data set that we're using today, which is proteomics data, different from several years ago, which is microarray. So I feel that's really should be the emphasis of the methods development effort. Of course, any method we should incorporate the best prior, but these are complementary to each other. They're not conflicting. The only thing is that if you have a challenge competition, then there's an issue of in the end you want to publish a ranking. So in that situation, I would feel to separate the ranking for the prior and separating the method would less likely to generate a human conflict.
So to a large extent, I agree that actually there is some orthogonality between biological information and algorithms. Of course, the correct choice of biological information informs which algorithms are appropriate, so it's not exactly orthogonal. There's also some path dependence there. But the point that I'd like to make is that we know how to make algorithms reusable. That's relatively straightforward, it's easy. An algorithm that does well on some kind of a published data set and does better than the previous algorithm is immediately recognizable as useful in that context. We don't perhaps have well, in some cases we certainly have data sets and particular databases that are recognized as useful priors. But we don't have a good understanding for how to make a prior that helped win a dream challenge useful in either a real-world application or a different dream challenge that perhaps involves that type of data as well. Or if it's clear to somebody who has spent a lot of time figuring this out, it's not necessarily broadly recognizable. So it might be interesting to think about a way of coupling the prior development and the algorithm development in the same competition, maybe different teams both competing for the best prior and the best algorithm simultaneously, and maybe even having a process that evolves where an algorithm can choose to use a different prior going forward, something like that.
Okay, before, instead of continuing along this line, I think that we discussed enough. I wanted to ask a few questions to people, or at least trigger some couple of other lines of thought. One is, I am concerned that we are, we just announced the Dream 8.5. But I am myself concerned that we are overdoing it. Like maybe if we have too many challenges, people are going to start to suffer some sort of challenge fatigue. And so I wanted to ask you guys whether you think that it's a good thing to have challenges every year, 2 or 3 challenges, so that people finish one and start another. People are learning anyway. Students have new topics to discuss, or whether this is, overdoing it. So I don't know whether anybody has ideas. So.
I may be biased, but I immediately think that different challenges are going to bring different communities of informaticists. I think the imaging challenge might bring people who might never have heard of DREAM before, but would immediately go, oh, that's a really interesting problem. So from my argument, I would say having more is not a problem as long as they aren't very closely conflicting.
So I think not that you're overdoing it if you continue, but I would, from my imagination, what I saw the last 3 challenges, I thought it's maybe changing a little bit too rapidly. So if one or the other challenge would be maybe just a little bit modified, like post again in the next year, so it gets more continuous flow, which not every year something completely new happens, let's say, then maybe this might be an advantage, I think. Yeah, so if you change the setting too dramatically from one year to the other, then you might not be able to set it into relation to the last year's results because the setting was changed maybe too much.
You know, the part of this is that we don't have an infinite supply of data, right? So data is, so sometimes we do what we can, but that would be ideal.
Just my own opinion, I think the new three new challenges are very, very exciting and has very important scientific contribution. But I think just from my own opinion, I feel it's a little bit too frequent to have two challenges in 1 year because we have to handle many other things, but we also don't want to miss the opportunity to participate in this very interesting topic. So.
Thank you, Yang. Marcus.
Did you guys hear that? We'd be if people were interested. I bet you could convince us to do more than one. We gain a lot from it. Like I really enjoyed watching these. So, I mean, that's one place where you could see it's all. Because I thought the same thing. It's almost like the DARPA Grand Challenge with the autonomous vehicles, right? The first time everybody totally failed, but then they made it harder and harder, and people were able to make something look easy that I thought wouldn't be solved for a decade. So that's pretty nice.
Dan, do you have a suggestion there? Because where are we going to get the data, for example, for clinically important diseases and problems?
Yeah, I've also wondered about, the saturation of the field. I'm torn between the idea of bringing in, as we sort of challenges emerge and different questions are being asked, and even in the area of cancer, we seem to have one every round. Whether we're tapping the same community or are we getting new people to participate in this. And as you said, Gustavo, one of the big challenges is where we're going to get the data to generate these. And I think if, we had heard some comments about the quality of the data and I don't think that's going to change because it's real data in that sense. So I think, I kind of like the once a year thing, though I can see in cases where we can generate the data and synthetic data in that regard, that you would possibly be able to do that, and that could fill in that sense. But I think, the challenge is to make sure that we have good, reliable data that can, especially if we get into more of the clinical settings in that regard. So I'm a little hesitant about trying to sort of, I think it's a proper number. Plus, I think the also in terms of the infrastructure, the work that you do, where it's a lot of voluntarism too. I don't want to underestimate that the workload there too, and I don't want to see the quality drop there also.
Thank you, Dan. Maybe I want to ask another question in a second, but let's finish this one.
So I have a friend who is a biomedical engineering student, and she is very interested in the Dream Challenge, but her major is not in these computational bio topics. So maybe it's a good idea to put in more diverse topics there, like image analysis, functional MRI, things like that. That's just
I'm afraid we would lose our soul if we do any kind of challenge in a way. We started as a systems biology verification kind of setting in order to understand whether our algorithms are correct or not. And if we start to do any kind of challenge, there are other people who are doing it. So I want to change a little bit the subject and maybe use this to finalize, unless there are final thoughts from different people here in the audience. But one thing that we have heard repeatedly, and it's as I said before, we had a reason to do the way we do it, but I think we will have to change it, is the fact that people want to know beforehand what is the metric that is going to be used to solve the problem. And let me discuss 1 second what is the problem here. There is this concept that if you know the metric, you will try to game the system. That was something that has been seen in CASP repeatedly, in which people are trying, if you're going to do this RMSE, then I don't care about some areas of the protein. Maybe it's important, the functional parts of the protein. What I want to do is to make my protein as close as possible so that I win the challenge, and not think what are the important domains and so on. So this is an example in which they, in CASP, where we get some inspiration, they don't give the scoring function right away. And that's one of the ways we are also thinking. If you are trying to do some sort of optimization of the precision, then maybe you put all ones or all zeros to win. But what good is that? And I'm not sure. I mean, we can change the metric, but and then there will be some other way in which people will think, ways of, the criminal mind at work in order to solve the problem, rather than trying to solve the problem in earnest. But I know that it's a different way of thinking, because the participant wants to win, and the organizer wants the problem solved. So it's a different kind of optimization function. But I want to ask, to some extent, from you, having heard our way of thinking and having experienced your own way of doing things because you participate, whether you are okay with our way of thinking or you say that's crap.
So I'm a very suspicious and paranoid person by nature. I'll begin with that. And I don't care what metric is being used so long as I know that I'm not chasing a moving target. So I think the most elegant solution to this problem is you send out a text file which is encrypted, and you say at the end of the challenge, we'll provide you the cipher, and you'll see it'll turn into readable English text. In this competition, we aim to use the following. So that way, everyone can hold you guys accountable. You said you were going to use this scoring metric. You encrypted it. Day one, everyone had it in their email box, right? And as long as I know that we're all competing to optimize the unknown cost function, and the target is not moving based on how the organizers are seeing it shake out, I'm fine. So that's my solution, so that no one can game it, and we can't be gamed.
Okay, and who would you trust to keep that the cipher decryption?
So I think that it's not necessarily a contradiction to having to providing the scoring metric at the beginning of the challenge, but preventing that people submit some results that are not that are not in your are not forthcoming somehow, that don't provide insights. I mean, for example, parameter distance and prediction distance, it's absolutely reasonable, and you can use it as long as you don't provide it during the challenge to the participants. So I don't see the problem, actually.
Well, just to comment that there is also, I think, the aspect that, and this was in one of the challenges, that we think a metric is the good one, but then as you run the challenge, you realize that this metric has its own problems. And so in some cases, like the parameter estimation is a maybe well-defined case, but others it was things that you cannot anticipate unless you have run the challenge.
Right. In the toxicogenetics challenge, we said, well, we discussed with Ivan and Fred, they say, well, what matters is how close your prediction is to reality. So let's use RMSE. Makes a lot of sense. But when we did the leaderboard with that, we started to see that the RMSE didn't distinguish the submissions at all. And so we were trying to understand why this metric that was reasonable. And we said, when we wrote the challenge description, we said it will be RMSE and maybe others, because we always know that we don't know beforehand until we see the data, what blindly, we don't know who are submitting. That's why we prefer team names that are not revealing of who submitted and who doesn't. But so at that point, we realized the RMSE doesn't tell us what we want to tell, which is the dependence of the EC10 in that challenge on the individual, on the genetic information. So we decided to change it. We gave a webinar, and we said, these are the problems, and this is why we changed it. So there was, a moving target, if you will, but it was based on the fact that we are not just trying to find the best performer. We're trying to solve a problem, and we saw this metric is not going to lead us any closer to understanding what solves the problem, which is genetic dependence of the EC10. So that's why we reserve ourselves the right to do that, because we have been doing this for 10 years. So we kind of understand, and we understand the frustration of people, but maybe we have to change it. Maybe we have to do what, Sakelario says, let's put one way of doing it, maybe we don't reveal it, but at least everybody knows that there is no cheat.
Okay, so I have a couple thoughts running through my head. I'm not sure if this is going to make sense or not, but it seems, I mean, a lot of us here are quantitative by nature, so I think there's, we have a gut instinct that we want to have objective, quantitative means of measuring different participants. And when I first started working or participating in this competition, that's definitely what the overt message was. It's, whoever optimizes this function ends up winning. But I think that you might want to distance yourself a little bit from that, and at the beginning of the competition have a more open and qualitative disclaimer that says, look, we're looking for people to come up with the most creative method, and we will obviously evaluate each method in quantitative terms, but in addition to submitting your method and your final value of the cost function, you should also submit an abstract, a couple figures, and a short discussion of what you did. And we will select the write-up that we think solves the problem the best or is the most creative or something. And I think at the end of the day, there's nothing wrong with going for those qualitative solutions over the more objective quantitative ones. And then the one drawback that comes to my head with that is that it's a lot of work to write up an abstract and make figures and sort of write a mini paper, and people might not be willing to do that if there's no guarantee that nothing will come out of it if they don't get selected. So one way to get around that perhaps would be to have everybody submit a short write-up and then have some way of quickly peer reviewing it and putting it as like an open access, like fast, rapid publication similar to maybe like F1000. I don't know, these are just ideas.
That is an interesting idea, and along those lines you might imagine that a significant part of a challenge, or even a challenge itself, might just be to come up with, like, here's the problem, you come up with the metric, right? So like, that could be very interesting.
Crowdsourcing the metric, I think that's a good idea.
I think one of the common themes here is about how much should be open or revealed in a way. And it's one of the things that we thought about a lot was, should what contestants have done be revealed to other contestants during the course of the challenge? And so Josh and I disagreed on this, and I basically felt that that has a big risk of bringing people down a local minima or up a local maxima, because people will see the successful strategy and just say, oh, we're going to modify and tweak that. On the other hand, it prevents you from potentially learning a lot. And there may be approaches where you kind of keep it closed for 4 months and then allow ensemble methods or methods that would use the techniques of other groups for the last couple of months of a challenge. I'm curious what people think about that. Is that an appropriate solution, or is that something that is too much of a hybrid challenge?
So in the breast cancer challenge that we did last year, we had this problem of what we call a monoculture. The best performer was the best performer, everybody did that, and then nothing else. So you break the wisdom of the crowds because you need independence. But what we are doing now in the breast cancer network inference challenge is we have a competitive phase and now a collaborative phase in which now everybody can see what everybody did. And so I think that could be a paradigm, for getting the best of the two. Okay, I'm ready to close the discussion unless anybody else has something else burning to say. Okay, yes.
About the in silico data, whether it's going to be included as part of the, is there any, because I know you mentioned we will discuss this in a little bit, so I was just curious, especially for us that we weren't allowed to get the money so from NCI. I guess more than anything else, we're just interested in the team. I'm sorry, yeah, just to actually make sure that if the in silico data will be included as part of the publication.
Yes, so with respect to the in silico data, so, internally we also have a number of people that told me, this is with respect to the breast cancer challenge, right? That is the one that Joe commented during the discussion. My feeling, because, to reveal to you what happened when we were discussing with Nature Methods, is that they said to me, you are using 4 cell lines on breast cancer. This is nowhere close to real breast cancer. We are not interested almost in publishing until Laura explained to the editor that these 4 cell lines are actually chosen so that they represent the types, of the heterogeneous types of breast cancer that there is. Based on that information that I had in the discussions with them, that they didn't even were interested in the challenge because we were doing in vitro. I have the feeling, even though I didn't validate it with them, that they will not be interested in the in silico either, because they already said that the in vitro, the cell line, is not close to the biology sufficiently for them to be interested. Because of this, I said, first there will be less interest from Nature Biotech. On the other hand, Nature Methods. On the other hand, there will be so much material that probably the best thing is to take the in silico people to write their own paper and submit to another good journal and make the comparison with the experimental. So that was an idea. It wasn't. It is not. It has been. It's being discussed. And probably we will have to discuss it amongst the people that will be part of the paper. But at this point, what I'm thinking is what we should do is try to convince Nature Methods to take that paper with a different set of authors from the one that highlights the experimental, even though everybody will be part of the DREAM consortium. The authors that are not in the DREAM consortium part will be name by name. And so that's what we are thinking. So maybe we can go and say, we will send 2 papers. But we are still debating that, okay? So the alternatives are, we'll put everything in one paper, experimental and in silico. We separate for Nature Methods. We separate in 2, both to Nature Methods and see what they say. Or we submit to another journal that might be interested in it. So those are the 3 options. Now, we are not trying to, take away credit for anybody. Okay. Thank you very much, everybody. It was very useful. And yes, I'm told whoever is coming to the next few days of the conference, please keep your badge, because this is the badge that will allow you to come in. The idea is that you don't have to re-register or anything like that, but keep your badge, don't throw it, and use it, because there is a person back there that will check that you have this, and if you don't have this, they will ask you. Thank you very much again. It was a very intense set of challenges. We are coming to new, very intense set of challenges. I hope you keep participating and don't get discouraged when we make mistakes. Thank you. Bye-bye.